Good morning. Today we are going to discuss about decimation and interpolation. In other words, it could also be referred to as downsampling as well as upsampling. So before we go and learn what is downsampling and upsampling, let us understand what is sampling. So when we take a continuous time signal, we could able to discretize the signal with a different interval. And if these time intervals, the discretized time intervals, are maintained at a regular time intervals, then they are referred to as the sampled time period. Such signals is very essential in order to, when we go for sampling, converting the continuous signal into a form of a digital signal. Therefore, the sampled signal xn of t will be given by which are sampled at the n intervals. To emphasize further, it also should obey the principle of sampling theorem. That means the input signal must be the operating signal in which we are going to perform this kind of a signal should possess the frequency which are higher than twice the higher than that of the input signal, and such rate we call them it as a Nyquist rate. If it be there exceeding the frequency of twice that of the input frequency, then we could avoid the effect of aliasing, or in other words we call them it as overlapping. Downsampling. So basically downsampling refers to a sampling rate of a discrete time stage signal by reducing the sampling. The sample rate of any discrete time signal, if you are reducing by a factor d, then the particular signal will be referred to as a decimation signal, downsampled signal, and it is represented as y of n, which is denoted by x of dn, where d represents the amount at which it is downsampled with respect to the given input signal. Now let me consider with an example 1 2 3 1 2 3 and 1 2 3. If you want to downsample the signal at a rate of d is equal to 2, then we will pick all the signals which are sampled at 2, and the remaining samples will be totally removing from the analysis. Similarly, when we take x of 3n, the 3 represents here is nothing but we are going to consider the signal which are sampled at a regular intervals of 3. Whereas the other samples, other than the 3rd, 6th and 9th samples of the given input signal, we totally remove from the analysis. So our ultimate aim in case of both downsampling as well as an upsampling is nothing but the aliasing or overlapping should not be there with respect to the input subsequent signal. So in such cases, or in general cases, normally the given input signal will not be in a band limited form. So under such cases this problem may exist, but when we go for a band limited signal, then that problem of aliasing can be totally eliminated with the help of filters, and that filters we normally call them it as anti-aliasing filters. Generally a low pass filter will be used in order to remove the effect of aliasing or overlapping. So the combination, so before we downsample a particular signal, we should ensure that these things has to be done before. So to do that, we will have a filter followed by the downsampler, at what rate you want to be downsample the given input signal, and then the corresponding output. So the combination of this filter plus the downsample is referred to as decimator. The decimator also we can refer to as downsampler, upsampler or undersampler. Decimation rate compression is nothing but it is reducing the original input signal sampled by a rate of n value. The figure depicts the same thing. The first signal of the figure A or figure 1 represents the x of n as it is, whereas x of 2n and x of 3n is plotted in the subsequent plots of 2 and 3. We could infer that x of 2n is picking only the second, signals which are sampled at time intervals of 2. Similarly, except 3n is taking the signal or plotted the signal or picked the signal only the signal sample at regular intervals of 3, whereas in both the cases we can see other than the value of t, the all other samples are totally removed from the analysis. So as we clearly mentioned in the previous slide, decimator is nothing but the combination of the downsampler rate followed by a low pass filter.